A position sensor is a device that measures the linear or angular position of an object and converts it into an electrical signal. Position sensors are used in various applications, including robotics, automotive, and aerospace. Here's a brief overview of the principle, construction, and working of a position sensor. Principle. The principle behind a position sensor is that it uses a physical effect or phenomenon to measure the linear or angular position of an object. When the object moves, the physical effect or phenomenon changes, which is detected by the sensor. Construction. Position sensors can be classified into several types based on their construction, including resistive, inductive, capacitive, and optical sensors. A resistive sensor consists of a resistive material that changes its resistance when subjected to linear or angular displacement. An inductive sensor consists of a coil that generates an electromagnetic field, which changes when a metallic object is moved linearly or angularly. A capacitive sensor consists of two plates separated by a dielectric material, which changes its capacitance when the object is moved linearly or angularly. An optical sensor consists of a light emitter and a receiver, where the receiver detects the light that is reflected or interrupted by the object. Working. When the object is moved linearly or angularly, the resistance, electromagnetic field, capacitance, or light changes, which is detected by the sensor. This change is then amplified by a signal conditioning circuit and converted into an electrical signal that can be measured and analyzed. Position sensors are available in a wide range of sizes, linear or angular ranges, and accuracy levels, and are used in various applications such as machine tool position feedback, robotic arm position sensing, and throttle position sensing. The selection of the type of position sensor depends on the required linear or angular range, accuracy, and environmental condition.